Welcome on my channel. Today I want to talk about LEDs and how to wire them up into a locomotive or whatever. Basically I want to talk about current control, not about voltages as much, but to control the current, maximum current that's flowing through this LED. Why? Well, this LED is hooked up to my power supply over here, and don't know if you saw that, but it's currently running at about 3 volts and I don't know how much amps. What I will do is ramp this power supply up, because I want to install this into a wagon on an analog railroad, and I'm just gonna crank the power up. Now I'm having the light on and it's nice and it glows, but then I start to turn the voltage up. Now you see the LED becomes brighter, just like a normal light bulb. Now I'm at about 5 volts and let's see, hey, it becomes dim. I'm at 6 volts roughly, and it starts dimming even more. It's off. It's out. What happened? Turn the voltage up. 20 volts. 30 volts. It died. Why did it die? Because the current flowing through this LED at 6 volts was too much. The LED simply burned out. I'm on an internet forum regarding garden railroading, or at least the big scale trains, and there was a little thing about a man who made interior wagon lights, and he used a bridge rectifier, an LM317 like this one, and some LEDs. Now he did this one, the LM317. It's a it's an adjustable voltage regulator. That's the word. Now he didn't use it as a voltage regulator. He switched it as a current regulator. And yes, you can do that with an LM317 or any voltage regulator. I discovered you can use as a current limiter or current regulator. So we're going to see what an LM317 does, and we're also going to see something else which another guy came up with, and he used this one. This is a J FET. Specifically, it's the J FET BF256B. So I don't know if probably another J FET will work similar, but he used the J FET also as a current limiting device. Now the basic thing is that with the J FET he only uses the J FET and a couple of LEDs. As with the voltage regulator as current limiting, you also need a resistor. But first I want to show you, as I did just now, the LED just popped when you give it a little bit too much voltage. The current will go way too high and the LED will break. What you can do about it is put a resistor in series with the LED, and that is something you can do, because if you're running on the same voltage, then there will be no problem in powering the LED from with a resistor as a current limiting system. Now this is a 220 ohm resistor, and we're going to hook it up to the breadboard onto an LED, and we'll see what will happen. Let's do that. First, let's look at the schematic, which we're going to draw up now. And we have a power supply here, a positive. You can see a bit closer. We have the positive power supply, power, and we have a negative rail. So this is positive, this is negative. I'm not gonna go into how to control that in a model train or something, because then you have the polarity switches. I'm not gonna go in there. First we're gonna get the resistor, and some guys draw it like this. The resistor, and it's a 220 ohm resistor. And then we're gonna take the LED, which is basically a diode, simple like that, with some arrows pointing away from it, which tells us it's an LED. So LED. There we have it. Now the resistor will limit the current through the LED, and when we put it on a breadboard, we're gonna put our LED in here, get the resistor, put it in series with the LED on our breadboard, hook up the positive power supply power, and hook up the negative. So there you have it. That's our schematic. Our LED works because this is a relatively new, this is a modern LED, and it doesn't take a lot of power. Now 220 ohms we use for Arduinos, if you are familiar with that. So you can ramp the power up to about 5 volts and nothing will happen. The LED is nice and bright, so nothing will happen. However, again, if you use this in a model train as interior lighting or something else, you will go up higher in the voltage. So easily 10 volts I'm now at. I'm now at 10 volts. Can I show it to you? Yes, I probably can. We're running at about 8 volts right now. So when I crank it up, the voltage will go up 13 volts. The LED is still fine. Why? Well, because we have the resistor in series, and it will take a lot of current voltage over the, and you can see basically 25 volts, 28. Now something is beginning to smoke. Don't know if you can see that. It's actually smoking here. Yeah, you can see it on the camera. Now what is that smoking thing? That is your resistor, because your resistor is basically having a voltage of over 27 volts standing over it. If I will measure that, you will see 26 volts roughly over it, and it is it's drawing a lot of current through there. So it's basically heating up. LED is still fine, luckily. But this is something you don't want. So I'm gonna throw the voltage down now, dropping it, and go back to 5 volts roughly. There we have it, 5 volts. So LED is now on, but the resistor, I will show you. Take it out of the schematic, and I even burnt my molten my breadboard. Here you can see that. There, it burned. Stupid me. Well, and you can see the resistor is basically it's ruined. Ruined. It will still work, but it's charred black. That's not the way we want to work with an LED. Now you can do something else, and that's with the JFET, and I want to take a look at the JFET first. So now let's take a look at the JFET schematic. That's our little JFET lying over there. With a JFET you don't need a resistor or anything else, you just need the JFET and the FET and an LED. So we're gonna draw the LED first. There it is. Again, the same way as it's up there. Only difference is we're gonna install a JFET. And I'm gonna do the schematic symbol for a JFET over here, which is this. And this is how it's looking. Now, this is the source. This is the drain, and here we have the gain. And this is basically how you connect it up to in your circuit. That's it. Nothing more, no fancy things, just like so. And this will let the LED go at his working current, and you can apply a voltage as high as you, relatively as high as you want, of course, because this JFET has a working voltage, maximum working voltage of about 30 volts. So you cannot put it any higher, but it will do the job and you can use that. So now we have it, we're gonna put it on our breadboard. I already stuck it in, and we're gonna hook up some wires. Now this one has the schematics in such a way that the center pin is the source, and that's this one here. This is the center, so I'm gonna put that in there. That's the center, and we're gonna hook that up to our voltage supply. And now this pin here, the first pin, we'll zoom in a little bit. Now the first pin here, that's number 1, and that's the drain. And this pin, number 3, I call it, is the gain. So in the circuit, the gain is connected to the drain directly. So I placed this little jumper in there. So that's the thing we need. And now we're going to hook up the LED. And as I just said, the long one is the positive and the short one is the negative. And I'm going to stick in a wire for the negative as well and hook it up to our power supply, like so. And you can see the LED lights up. This is on 5 volts, and I will show that to you again. Zoom out a little bit. Oop, zoom out. Oop. Put the meter in. Oop. Now if you don't get queasy, stay with me, don't run to the bathroom. Let's see how we hook this stuff up, like so. Stick him in like there. We're gonna do the same for the negative. Get him in there. So, as you can see, we're at 5 volts, and let's see what happens when we ramp up the voltage a little bit. Slowly, 8 volts. LED is still same brightness, nothing changes. 13 volts, still nothing happens. You hear the click maybe. That's the power supply switching to a tap for higher voltage, because it's a power supply which is based on LM317. So 25, 26, 28, maximum voltage. You see, nothing happens to the LED, and I can even touch the the FET. It's not getting warm. The resistor melted my breadboard, as you can see here. but the LED is just nice and functioning. Turn the voltage down, and this is not the lowest voltage. I can go to 0. When I slowly ramp up the voltage, we'll see when it will turn on the LED. 2.8 volts, it comes on. 2.4, it will dim a little bit. 2.4, it will stay. Well, it will stay nice and bright from about 4 volts. So that starts at 3 volts. So there we have it. We have a nice device with 27 volts, 30 volts, 30.4 volts. Everything is fine. The LED will stay on nice until we drop it about 2 volts. Let's see how 2.2, 2.4, then it starts to come. There it's slowly coming on at 2.4, 2.3 even. So nice low voltage when it starts up. Now in his thing he said you can place more LEDs in series behind it, and I think that we should do that. Take out that one, put it in the right way, stick it in. There we have 2 LEDs. Hey, it's not turning on. What's happening? One will turn on. If I take the second one, it will not start. Why is this? Let's see how much volts now we need to get the light to turn on. The 2 LEDs, 4 volts, 4.7, 4.8. Yeah, oh, there they are. 4.7. 4.7 roughly, and then the LEDs come on, and then we are at 5 volts, and now even at 5 volts, 6 volts, they're nice and bright, but nothing, sorry, lose contact, nothing is getting warm. They will work fine. All the way up to maximum voltage, yes, nothing happens. Now I have put these LEDs in series, and that means that the voltage you need to for them to light up doubles. So that's not nice. Let's see what happens, and I haven't tried it out myself, if we put them in parallel. So they're now in parallel. Poof. They come on. And again, we can control them. Roughly 2.4 volts. And then it's okay. Turn up the voltage again. 30 volts, still nothing wrong. This is nice. Hadn't tried this out yet, so now if you're wondering how much current there is flowing through this thing, I will take the meter and put it into current mode. So there's not a lot of amperage running through these 2 LEDs. If I ramp the voltage up, and I will tell you I'm now at 15 volts. We have about 8 milliamps, and these 8 milliamps will stay roughly the same. So these LEDs will light up at 8 milliamps. Thereabouts. No, they don't take a lot of current, so about 0.04, really low, half a milliamp, they will come on. So that's nice. But the milliamps will stay exactly the same no matter how high I put the voltage. And that's what this JFET does. It controls not the voltage, but it controls the current that flows through the LEDs. And it works great. Now, normally you don't put a lot of LEDs in parallel, but I'm gonna do it anyway. Hook that one up there. Fit. So, nope, the other way around. Stupid. 3 LEDs. Current still the same. I haven't changed the voltage. Current is still the same, and nothing will happen. Whoop, there they go. At about 2 volts, as we had in the other. Maximum voltage, full on, everything is going. 8.3 milliamps. 3 LEDs, and I can get the voltage all the way down. This is about 4 volts. Yeah, no, 3 volts. So just about where they cut out, but you can easily ramp it up and the current stays the same. So basically you can put more LEDs behind it, but it's not recommended to put a lot of LEDs in parallel, because one LED can draw a little bit more current than the other one, so the brightness is not always the same. If you put them all in series, the voltage where you will light them up will double or triple even, so that this one you should already have about 7.5 volts for it to turn on. And as you can see, the current is dropping a little bit. It's now 7 milliamps, 7.9 milliamps roughly, and it's slowly dropping. Don't know if the JFET is getting warm. It is at 30 volts, so no, JFET is still going strong. It shouldn't get warm because it's only 8 milliamps that are flowing through its body. It's not major currents. Well, I'm back again. I checked my circuit and I cannot find it now. When I checked it earlier or a few days ago, I worked with it and it worked. I could adjust the current here with my potentiometer. Only a little bit because it's a 10K potentiometer. But I could at least change the stuff around. But now nothing happens. I can try just one as a thing. How is that? Oh, yeah. I'll try one more thing. I will hook the sweeper up to the other side of the potentiometer, basically making it a little bit different. See if I can now change the current. Nope, nothing happens. I even have put in oh, I'm back now, and it's a day later. And yesterday when I started filming on this stuff, I made a little mistake. I thought the pins on this LM317 were input, adjust and output, but that's not the case. Silly me. That's only the case for an 7805, a 78012, a 7812. Those kinds of voltage regulators. For the LM317, it is the first pin is adjust, the second pin is the output, and the third pin is the input. Stupid me. And that's why I got this schematic here all wrong. So we're gonna do the right schematic now, and we're just gonna flip the page over. So As I said, the first pin here is the input, is the adjust, and well, that's the one we need. So here we go. I'm gonna draw our positive rail, and we're gonna draw the negative rail over here. Negative. Put in the LED there and hook it up. And now we're gonna draw our LM317. Now, drawing it a little bit bigger so as to see what is happening. This is the adjust line and this is the input. So this one needs to go over there. This one is the output and it will go via a resistor, which I forget to draw in, to the LED, like so. The adjust will go here and then also hook up here. Now I'm gonna use my potentiometer here for this thing, and I say let's build this device. So let's build the circuit. First we're gonna stick in our LM317. We're gonna get some LEDs. A little bit too hard. So push one in. Maybe I'll get two of them. Why not? No, three even. Wow. So 3 LEDs are going in. That's like so. And now we're gonna hook up our input of the LM317 to a positive of our power supply, and I've done it here. So that one goes to the positive of the power supply. We're gonna do the output. We're gonna connect it, and I will make a little bit more room on the board. Like so. Stick them in. There they are. I'm going to do the output of the regulator to one of the pins, and I do the center pin of my potentiometer. Now I'm using a potentiometer because I don't have a resistor with the right value probably, so I'm using this. The other side of the potentiometer goes to the LEDs. Also, the adjust of the LM317 goes also to the LEDs. And I will put it in here, like so. So this is our circuit. This is how we're gonna use it. Of course we need a ground. Let's stick that in and hook that up to the ground of our supply. And again, if I'm holding it just by hand, I'm not touching anything else, they're lighting up. So some ground loop error here and there. I put the meter so I got the meter on 200 milliamps. I think I even so. Now we're gonna up the voltage on our power supply. and see when the LEDs come on. There they are, and that's roughly 3 volts, roughly. Now they are nice and bright, and we are pulling, go one scale down, 0.8 milliamps. Gonna go higher. They're bright, they're really bright. So we're now 3 milliamps, 5, 10, off scale. Whoa, what's going on? Ah, that's what's on. I can, of course, I've put the potentiometer all the way in this direction. I rotated it this direction, so basically there was no resistor in the circuit, but I can adjust the current by rotating the potentiometer, and you can see the current coming up and the LEDs brighten up. So let's say about, whoa, that was bright. It's really sensitive, but thereabouts. So you can see that the current in the circuit is 8.5 milliamps, and I'm running at maximum voltage on my supply, which is 30 volts plus a little bit. So you can see the current will stay nice and the same, even if I drop the voltage again. I'm now at 10 volts and we're still at roughly the same current. Only when I'm at, well, let's say, oh, when I'm at 5 volt, the current is 3 milliamps, and when I'm slowly putting it up, the voltage will, or the current, and the voltage is now 5 volts exactly. No, a little bit more. This is now 6 volts, and the current is 8.92 milliamps. And when I'm at 10 volts, the current is 8.94, and I can go all the way and it will stay roughly the same. Only beneath 6 volts the current will drop, and that has to do with the voltage across the resistor, which has to be 1.25 volts, and I think that's where they were, that's the problem here. But you see that the LEDs will come on at, well, 4 volts, but they will not get the same, they will not be their brightest until you get about 7 volts, thereabouts. No, 6 volts. So at 6 volts you will get the brightness you want, and then the current will stay the same all the way up to 30 volts. So yeah, now it works, and I can regulate the current here with the potentiometer. I can dim it. So that's nice, you can dim the stuff with it with the potentiometer. So that's basically it. So this was the video about current control and LEDs. Hope you found it interesting. If I left something out or did something wrong, as I did do something wrong, I messed up a circuit. So luckily the LM317 is a pretty forgiving piece of equipment. It will stay alive for a long time. This is an ST Silicon Technologies one, so it's a branded one, and they are absolutely fine. They are current protected and everything, so temperature protected inside, so they will stay alive. This was the video, and I hope you enjoyed it. Stay tuned or subscribe for more videos, and hope to see you back soon. Goodbye.